So we are going to develop a state-space model for this RLC series circuit, and the first step is applying Kirchhoff's voltage law, which states that the summation of the EMFs minus the summation of the voltage drops across the circuit is just equal to 0. So my EMF is just the applied input voltage, and my voltage drops are the voltage drop across the resistor, the voltage drop across the inductor, and that across the capacitor. So from Ohm's law, I know that BR is just IR, and the voltage across the inductor is just L di dt. And my I is the same current following through the resistor, the capacitor, and the inductor, because we are dealing with a series circuit. And that is equal to C dBc over dt. So substituting 2 into 1, we'll have equation 3. And the second step is just the state definition. So states are just system variables that you want to use to analyze the behavior of your system over time given an applied input. So you can have different definition of states. The states you use decides your state space model. So in this case, my definition of state are S1 is just the current and S2 is the voltage across the capacitor. So these are the states that I want to use to analyze my system behavior over time. So the next step is model formulation. So from the state definition, substituting that into 2, which is this equation, I will just have x1, which is I, is equal to my C S2 dot. So making S2 dot the subject of the formula, I will have A, and substituting the definition into 3, I will just have B in minus R times S1 minus L times S1 dot minus S2 is equal to 0. So making Si dot the subject of formula, I will have B, and from the circuit, my B out is just the voltage across the capacitor, which is equal to S2 from my state definition. And let me name my B in U. So from A, B, C, D, these are my state space equation. And representing them in matrix form, I will have this matrix equation. So you can go through S1 dot just to prove that it is correct. So S1 dot is just minus R over L times S1 plus minus 1 over L times X2, which will give you this part, then plus 1 over L times U. So doing the same for S2 dot and Y, you will see that this is the correct state space matrix form. So given this resistor, inductor, and capacitor values, my ABCD matrices will be this. Now let us jump to MATLAB and Simulink to see how we can simulate this system. So here we are in MATLAB, and I have already defined my A, B, C, D matrices so that I can directly call them from Simulink. So let us go to Simulink. So here we are in Simulink. I know that I need my state space model. I need an input that I will give to the system, and I want to also visualize my output. So the first thing is to double click and write state space. So click on state space. I can make it bigger, and then I will call this one RLC circuit just to rename it. RLC circuit. You can go to format and make it bigger. So double click again and write signal generator. So this is the signal generator. Then connect these blocks in order to have my signal. And I also need to visualize my output. So let me use a scope. So this is the scope connecting these blocks. So this is my input. I can name the input signal. So by double clicking on the signal, I can write input voltage. So this is my capacitor voltage, this signal. So I can also write capacitor voltage. For inline visualization, you can use a dash scope. So if I double click, I write dash scope. So this is my dash scope. I select it. I can make it bigger. So if I double click on it, I can select the signals I want to visualize. So I want to visualize my input voltage. I select it, and then I want to visualize my capacitor voltage. I select it also, then apply OK. So the next thing is to import the ABCD matrices you wrote in MATLAB. So by double clicking on the state space model, I'll just write my A, which is already there, write my B, write my C, and write my D because I've already defined it in MATLAB. So apply and then OK. I can now define my sine wave. If I click on the signal generator, it is already in the sine wave form. So my amplitude is 5, and let me choose a frequency of 1 over 20, which is 0.05 for low frequency simulation, and then I will change the unit to hertz. So clicking on apply, and then OK. So by clicking on run, so you can see this is my input voltage and this one is my output voltage, which is the capacitor voltage. So you can see the voltage across the capacitor is liking the input voltage, and also it has lower amplitude. So this is how you can use Simulink to simulate your RLC circuit. Please like and subscribe to the channel. Thank you for watching.